Guys, let's get started with a very important chapter, that is nuclei. I completed the first part of modern physics. Right now I'm continuing with the second part. Hope you enjoy studying with me. So nuclei is basically first, this is the first page of my notes. The size of atom is important, that is 10 raised to minus 10, and size of nucleus is 10 raised to minus 15. Now radius of atom is 10 raised to 5 and volume is 10 raised to 15. Okay, times of volume of nucleus. So this is this entire thing. Okay, and a fundamental particle is electron, while proton and neutron not fundamental, made up of quarks. So we need to know that. Okay, next we have this whole thing about the proton, deuteron, alpha particle, electron and neutron. This is very important because when we are solving other chapters also, this whole thing comes out. So just we need to keep in mind that deuteron is 2m with 1 electron. Alpha particle is okay, 4m with 2 electrons and plus 2 charge. This is the charge, and then obviously this 1 U or 1 AMU is 1.67 into 10 raised to minus 27 kgs, which is 1.67 10 raised to minus 24 grams. Then we have this rest mass, that is E is equal to mc square. Okay, then we go ahead to the proton ka thing. For proton it is 931.5 mega electron volts, while for electron it is 511 kilo electron volt. So you need to know about the proton and the electron. Okay, post that, when we go ahead, we have radius of nucleus. So radius of nucleus is directly proportional to a atomic number ka 1 by 3. Okay, so this is the graph like this. There are two of them. Then we go ahead to the volume of nucleus. Okay, let's understand about the volume of nucleus and the density of nucleus. Volume of nucleus is directly proportional to atomic mass number, while density is not depend on atomic mass number, and the value is 2.4 into 10 raised to 17 plus 17. Delta is independent of atomic mass, almost constant for all nucleus. So that was the next page. Is this is the solving example. We take it as 1 by 3 and then we solve this. This is another example of similar type, but this is for density, so 1 is to 1. Then this is very important, where it is asking about the velocity. So radius is directly proportional to radius is inversely proportional to velocity raised to 1 by 3 in this question. That's how this question is solved. This is the entire derivation done by conservation of momentum. Okay, next we have mass defect or binding energy. So if we have 1 kg and 5 kg things and they are together and we get it as like 4.9 kg, something like that. Each of 1 kg there are 5, and then when measured it is less than 5 because of binding energy. So delta m is equal to mass of constituent particle minus mass of nucleus. So that's like this. Okay, so over here the mass of constituent particles is more than the mass of nucleus, while binding energy is mc square, that is mass into delta m into c square, that is delta m into 931 mega electron volt. Okay, so binding energy per nucleon is this. Okay, that is directly proportional to stability. So if binding energy per nucleon increases, stability increases, energy is released. And if it decreases, instability increases, that means stability decreases, and it absorbs energy. Next, when we go ahead to this graph, in this graph, first the binding energy is increasing and then it's decreasing. This is nuclear fusion, this is nuclear fission. Maximum is for Fe, that is iron. Okay, normally it's for it is 8 mega electron volt. Okay, iron is 8.7 mega electron volt. Then N fusion or fission, in both cases bonding energy per nucleon is increasing, releases energy when we move towards stability. Okay, Then when we go ahead to the next part, this is a very important question. So after every chapter I have questions that are to be solved. So what we'll do is we have this chapter ending out here. This is the last page of the chapter, and after this chapter I will remove another video to do atomic, and then we can redo dual, okay, and semiconductors. So that's how the pattern will actually go, and we will complete entire revision in 3 hours. Okay, so when we move from C to 2D, that is C to 2D, energy is absorbed. Then A to C and D, D is नीचे, C is ऊपर, absorbs energy. B to C and D वापस absorbs energy. But A to 2C, as it is moving ऊपर, it releases energy. Okay, nice, because it's moving to more stability, therefore it releases energy. Next, when we go ahead, which is more stable, X or Y? बॉन्ड एनर्जी पर न्यूक्लियन का X का निकाला, फिर Y का निकाला, उससे we get to know X is more stable than Y. Then this is another question, bond energy delta mc square, remove delta m, then into 931 you get it in mega electron volt. Okay, that's, I feel, understandable. Then we go ahead to nuclear force, that is a strong force. Okay, for nuclear force, then EMF force, weak nuclear force, and gravity. Nuclear force is of short range, that is 10 raised to minus 15 meters, charge independent. So for proton proton, neutron proton, and neutron neutron, the force is equal. It is non-central, non-conservative, does not follow inverse square rule. It is attractive if more than 0.8 Fermi, repulsive if less than 0.8 Fermi, and this is the graph for it. After this, we go ahead to nuclear reaction. Now we have Q. Q value is reactant minus product into C square, while Q value for this in form of bond energy is bond energy of product minus bond energy of reactant. And then yeah, so when we were talking about Q, यहाँ पे Q for bond energy in form of that is product minus reactant, because when M of reactant is more than product or this is more than this, Q is positive, stable and exothermic. अगर उल्टा है तो unstable and endothermic. Now this is another question where they've given options and they're asking what can be the reaction. So the reaction is, okay, EA plus EC is equal to EA. Sorry, EB plus EC is equal to EA. Now this is not correct because it should be greater than the what. Okay, yeah. So then we go to second one. Yeah, that is also to 2, right? B and C. That means A forms B and C, and as this in energy form, so the energy of EB plus EC should be more than EA, and therefore the answer is the fourth option and not the others. I hope that makes sense to you all. Next, we are almost there, completing the chapter. So when we move ahead to bond energy per nucleus, when they've given that, we need to first remove bond energy. Okay, after removing that, we can solve the question, remove Q. Next, we have nuclear fission and nuclear fusion. So fission, bond energy per nucleon, in both of them bond energy per nucleon increases. Okay, these are the two reactions. When uranium is accepting 1 neutron, barium plus krypton and 3 this in 200 mega electron volt is the energy. Well, xenon is this, and then this is the energy. Average neutron is 2.5, liquid drop model, atom bomb, uncontrolled chain reaction. Okay, and this is energy per nucleon is 0.85, while for this 26.7 mega electron volt is the energy released, but per nucleon 6 mega electron volt. Energy per nucleon of fusion is more than fission. Example over here is hydrogen bomb. Condition of nuclear fission is high temperature and high pressure or density, right? Next we have this question out here. We have something called as amount of the question says that amount of energy released by fission of 1 gram of U235. So first we remove moles. After removing moles, we need to remove number of atoms. After removing number of atoms, we remove the energy. Okay, then neutron is unstable, you need to know that, and power ka formula is this. So it's Ne upon T, that is mc square upon time. Last part of the chapter and then the chapter is over, that is radioactive decay. Only unstable nuclei exhibits this property, and N should be greater than Z. Spontaneous emission of radiations from nucleus is known as radioactivity. Okay. Alpha decay, Z decreases by -2 and A decreases by -4. Like A decreases by 4 and Z decreases by 2, like this. And then kinetic energies formula there are two formulas. For alpha particle, the daughter mass upon total mass into Q, and for the daughter cell, it's mass of alpha particle upon total mass into Q. Okay, now then we have the next decay, that is the beta decay. Now we have beta minus decay and beta plus decay. In beta minus decay, the Z, the atomic number increases by 1. Beta plus decay, atomic number decreases by 1. In beta minus decay, an antineutrino and an electron is released, while beta plus decay, an positron, a positron and a neutrino is released. Then we have gamma decay, excess energy is released out in form of gamma radiations. There is no change in Z or A. Then this is the diagram for it, Rutherford experiment. Okay, alpha particle is positive, gamma is electromagnetic wave, and beta particle is negative. The ionization power is alpha more than beta more than gamma, while penetration power is gamma beta alpha, and deflection is beta more than alpha. Gamma does not show deflection. Okay, thanks for watching. Bye bye.